chemicals and fumes depicted in this demonstration video are dangerous. They can kill or injure you severely, causing immediate burns, blindness, or other long-term health-related issues. Mixing of the chemicals can cause undesirable reactions and/or results without any warning. All experiments must be done outdoors or performed under a fume hood. Proper personal protective equipment must be worn at all times. Be safe. It's your life. Enjoy the video.
Okay, today we're going to be converting silver chloride, AGCL, into silver oxide and finally into elemental silver. I dissolved some solution last night that I'll use in the conversion process. Oops. I have some sterling silver that I dissolved using 50% distilled water and 50% nitric acid. The conversion process that I'm going to show here today is by using the lye and sugar method. And the very first step, you can either use salted water. I don't have any made up at the moment, so I'm going to use hydrochloric acid or muriatic acid. Okay, you can find this usually in your local hardware store. Okay, let's extract the silver chloride. You can see all the white substance forming. That is our good stuff. Now, a lot of people use, I haven't heard much spoken of. However, this is not waste solution, okay? Here's a tip. You can reuse this solution. Be present. I don't know if you can see any of the white floaties, the things that look like cottage cheese. That's our silver chloride, AGCL is the chemical formula. Okay, we're going to let that settle. Now, because of time restraints, I am going to filter it, and I will process the settlement off camera. Okay? But process number one complete. Okay? We have our silver chloride converted. Again, you don't have to use expensive hydrochloric acid. You can dissolve a pregnant solution of salt, preferably non-iodized. However, if that is not an option for you, iodized salt is fine. The aim of the game here is to keep everything as free of contaminants as possible. That's why we use distilled water, as well as versus tap water, because, well, in this case, if we were processing a different type of metal and silver was present in solution, using tap water would start to pull the silver out of solution, causing you problems. All right. So I'm going to go ahead and filter this really quick, and then we'll continue on with the conversion process. Okay. Alright, I'll be right with you as soon as we're done. Okay, so I've decanted the most of the liquid from our silver solution. I'll pour this a little bit here off. We will collect all this later. One of the most important processes that any refiner can do is the rinsing, the washing. Okay, you want to wash away or with any sort of leftover contaminants, say copper in your solution and that sort of thing. The idea here is to boil up some distilled water. Actually, in this case, you can use tap water for this. However, I like to keep things consistent, and therefore I always use distilled water. And what you will simply want to do is wash your powder. Okay, you can see how it changes forms. Okay. The idea is to keep rinsing until there is no discoloration in your solution. So you can see there's still a hint of green in here, or blue. That's the remnants of the hydrochloric acid that we use to extract the silver chloride. And I'm going to do probably, well, you do as many washes as it takes, but usually 3 to 5, even sometimes 7 is necessary to rid yourself of all the contaminants. I can't stress enough how important this process is to achieve the highest purity possible. If you're going to omit this step and not do it, then why even bother doing any of it? Because you might as well just recover the metals, melt it, and sell it as is, and not even bother with the refining process. It's not a huge amount of silver by any means, but this is just for the video purposes. Okay, so starting to look, I'm going to do one more, decant this. Another benefit of using hot water or boiling water to rinse your powders, whether it be brown gold powder, white silver chloride, is that the hot water seems to pull all the material together instead of having it in very fine powders and such. See how it clumps up? That's another benefit. As many as it takes, ladies and gentlemen, even 7 times. Do not omit this step. Rinse your material. Okay? Now, let's move on. We now have this as AGCL, silver chloride. We're going to transition this material into, actually let me put it into a smaller beaker here. I'm going to just put this into a smaller beaker here. Last little bit. There we go. Okay. I'll decant this a little bit here. Now, I'm not sure if it matters how wet or dry your chloride is to proceed to the next step. Okay? I don't know if it could be submerged underwater, if that makes a difference, or if it has to be damp, moist. I prefer myself something to this consistency. Okay? It's not soaking wet, but it is wet enough. So, what we're going to do here is we're going to add in some caustic soda, also known as LYE crystals. You can find this at your local hardware store, or at least you can here in Ontario. And the idea here is to add enough LYE to make the silver chloride transfer to silver oxide. Okay? The idea here is to get it nice and black. We want it black. Not gray, but black. Now, depending on the amount of silver you have, this will cause, as you can see it already starting to bubble up. This is called an exothermic reaction. Okay? So if you're working with a lot of silver here, ladies and gentlemen, I would strongly suggest you put it under another dish. You can see the steam. I don't know if you can see that on camera, but it causes an exothermic reaction, causing it literally to boil immediately. You can cause a boil over it and lose some of your material, or you can also get injured. Alright, so be mindful of that. I think we're looking pretty good as far as the darkness goes. We have a small amount of silver, so I can't demonstrate the boil over, or else I will. I like to be the guy that says, I'll be stupid so you don't have to be. But if you are, there's simply no excuse for that. Alright? You want to make sure, lift your beaker, look underneath, make sure all the silver chloride, the white, is converted to this black stuff. This black stuff is now silver oxide. Silver oxide can be used in batteries, watch batteries, those type of things. The CR 2032s that are very common, and they're also used in photography, such as X-rays. The black on any X-ray film is this, your silver oxide. Okay, that's what's on your X-rays, on the the thin blue sheet laminate. The black is your silver. I'll make another video at some point showing how the process to silver off the X-ray films. It's quite easy, tedious, and if you have a sensitivity to bleach, you might want to not consider it. So our next step here, this is also going to cause a reaction. Regular table sugar. Okay, that's all it is. Regular table sugar, and this can be a delayed reaction. If you have a lot of silver, folks, be very careful. Add in a very little bit at a time. Okay, keep the reaction from becoming violent on you. I'm not too worried with this amount of silver, so I'm just going to go ahead and pour. I'm not sure if we'll have a reaction with it or not. It is a small amount of silver, but as the reaction takes place, it makes the conversion from your silver oxide into your elemental silver. And I don't think we're going to have a violent kind of reaction, so I'm just going to go ahead and mix this up. I can already see the transition happening from silver oxide into our elemental silver that we all know and love. Kind of looks like dark pudding. Again, as I mentioned before, this is going to be the rinsing process, which is hugely important. You want to rinse off all the lye, all the sugar, and be left with a substance that looks like wet cement, hence why they call it silver cement or cemented silver. Upside down, inside there, it don't matter. It's all the same. Alright, so I'm going to grab myself a new discard jar, such as this, and I'm going to rinse this. The conversion is complete. Maybe on one video when I process a lot more sugar, I will show you. Again, I'll be stupid so you don't have to be. You have no excuses at that point. I will show you what happens with a boil over. Okay? So, I'm just going to go ahead and rinse that. Decant that, and then use my watered rinse. I'm going to let this settle, this material as well. There will be some recoverable silver in there. If you put it to a torch, you're going to get a lot of junk. You're going to get a lot of caramel, and but through the mix and the clumps that you'll be left with afterwards, you will see specks of silver in there. So I'm very thorough when it comes to not being wasteful, so I will spend my time and let this here settle and recover the material from within. Plus there'll be some little floaties that go in there from the rinse process anyways, like that. You can see the material already starting to take form. Okay. Maybe I'll do it this way so you can see better. After this process is complete, we are off to the flame. Alright? And then it'll turn into, see how clear that's becoming now? You can put this to flame wet or dry. However, I would strongly again suggest that you dry the powder out for best practice. You can have crucibles explode on you from the steam, but if you're careful, and vigilant on what's going on, you can melt this stuff right from this beaker. Okay? But again, I suggest that you don't. 2 more rinses, and I'll be satisfied. See how clear that's becoming now? One more for the old skipper, huh? And there we go. What we have here is your silver. I would estimate that confidently as 99% pure. I don't know if it's 3/9 fine. I wouldn't go that far. However, I would say it's around 99 at least. 99.1% pure silver. There's different extraction methods when it comes to extracting silver, and I will go over those in a later video. But for today, it was the lye and sugar method, and I'm going to go ahead and just dry this out real quick, and then we're going to go ahead and put it to flame. Alright, I'll see you back when this is dry.